This is where it starts. I'll be sharing about Freon refrigerant. What is a Freon refrigerant? The HFCs and the HCFCs we know about. What are Series 9 refrigerants? A lot of people discuss about Series 9 refrigerants. What are the HFOs, the next generation refrigerants, the Opteon refrigerants? Then we also have fire extinguishing gases, which are also a part of the HFC and the HFO category, which help suppress fire. Then we have the Opteon 1100 refrigerant as well. So basically how it all started is that CFCs. CFCs were the earlier molecules. HCFCs came in after CFCs, which had chlorine inside, so which basically depleted the ozone layer. So in a refrigerant, the kind of properties we used to look for are either it has to be somewhere working around the ozone depletion, for which there is a parameter called the ODP. Now most of the countries have signed Montreal Protocol, as per which the ozone depleting potential has to be zero. We are already phasing out HCFCs, and we have already phased out a lot of them. Then the second parameter or the property which we look for in a refrigerant is the global warming potential. The global warming potential, the GWP. The second parameter which we see in the global warming is the total equivalent warming impact. And the third parameter which we see is the life cycle climate performance of a refrigerant. If you see this slide, so how the ozone is depleting is basically there is a O3 layer up in the stratosphere, and then the UV radiations from the sun come down, and the CFCs get released. They rise into the ozone layer, and then the UV gases released from chlorine form from CFCs, and they have a reaction in which ozone reacts with bromine or chlorine to make ClO molecule, and oxygen is made out of ozone. So that's a chain reaction which continues, and we keep on having the depleted ozone, and there's oxygen formation. So to take care of this, Montreal Protocol came into existence. India became a party of Montreal Protocol on 17 September 1992, and then it was amended later on. Multiple amendments happened, and 15th October the latest one was signed. Basically caters to the CFCs and the HCFCs phase out. For CFCs, we have already phased out the CFCs by 1st of August 2008 for RAC sector. HCFC phase out, the dates are already been marked. Base level for production and consumption is the average of 2009 and 2010. The freeze date is 2013, which is already done. We have already reduced 10% by 2015, and 35% reduction will happen by 2020. 67.5% of the refrigerants which come under HCFCs will be reduced by 2025, and then there is a 100% cut by 2030, after which we have only 2.5% remaining, which is there for servicing sector. Montreal Protocol also now takes care of the HFC phase down. A lot of people are talking about HFC phase down. So for HFC phase down, the base level for production and consumption has already been declared as the average. So India has signed in the A5 Group 2, which means that the average of 2024 and 2026 will be the base level for production and consumption. The freeze will happen at 2028 for the base level. In 10% reduction will be there in 2032. 20% reduction will be by 2037. 30% reduction will be by 2042. And there will be an 85% reduction by 2047, after which 15% of the available HFCs will be available for critical applications like fire extinguishing or pharmaceutical sector. Basically, for equipment manufacturers, this is the right time. There are opportunities for them. Either they transition to HFCs because HCFCs are being phased out. Like there are HFC refrigerants like 134A410, R32, or the mineral oil based alternatives, which I'll be discussing. Or they do the emission control by the design of the equipment, because There, for the existing equipment, they reduce the charge size, or they have a leak tight design, or there is an emission control during manufacturing, in which there is a control on the filling loss, and they do an effective recovery during the rework. For the service sector, basically customers need to understand and educate the equipment owners that HCFCs will be phased out. We need to work on newer alternatives which are already available. They need to take steps to minimize the existing HCFC emissions. Like if some building has an R22 chiller, they need to take care that steps are taken to minimize the emissions. They need to do the leak monitoring, and they need to take care of leaking of repairs. There needs to be an increased awareness of new equipment that is designed. So, for any new purchase they are planning to do, or any new equipment they are planning to buy, there should be an increased awareness that what kind of alternates are available in HFCs or HFOs, and what they can have as an alternative to buy. Retrofitting HCFCs equipment to ozone-friendly refrigerants is also an option. For the building owners or the equipment owners where the chillers or the machines are already installed, new equipment purchase policy has to be stronger and stricter. HCFC phase-out strategy should be there in place for the companies. They have to assess the risk of having HCFCs, and how they should be moving to HFC options. They need to prioritize that. They also need to determine the phase-out solution for existing HCFC machines they have, and how they can retrofit to alternate refrigerants which are available in the market. The last option, which is the most risky option, is that they can leave it as it is. Basically, they have to plan and budget for new equipment change or new refrigerant retrofit. They need to manage the emissions of HCFCs. They need to take care of leakage during the operation, and emission during the equipment maintenance has to be taken care of. For HFC phase down, Montreal Protocol also talks about HFC phase down. So for HFC phase down, we fall under, if you see this chart, we fall under A5 group 2 countries. So A5 group 2 countries says that by 2047 basically 15% of the HFCs will be available for us only for critical applications. So what are the alternatives? We have already developed, and a lot of companies are also working on some molecules which are the HFO based molecules. So HFOs are basically olefin molecules. There's a double bond between carbon, so they very fast or very quickly disintegrate in the atmosphere. They have very low GWP, and they are currently sought as the options for HFC. We have done the leading olefin investment globally for two molecules which we have invented. One is the 1234YF for replacement to 134A, and basically the second molecule is 1336MZZZ for low pressure applications. Some blends of this are being used as a replacement for R123 in centrifugal chillers. So basically, for a refrigerant, what kind of properties we look for is a balance of properties. Basically, it should have zero ODP, it should have a very low GWP, it should be non-flammable or mildly flammable as per the ASHRAE standards. It should have a minimal or a low initial cost. It should have a low maintenance cost. Commercially, it should be available, and the energy efficiency and cooling capacity should be high. So the options are available. HFOs are a valuable and necessary part of total low GWP refrigerant portfolio. We have them. Almost 60 plus molecules are already there and being commercialized. They are very low and low GWP refrigerants which give the optimal balance of properties for many applications, and they are commercially available and have proven safe and cost-effective track record.